Good day, viewers. Welcome to Smart Academy. Today, I'll be taking logarithm of numbers less than 1. In my previous videos, I've explained how we can calculate the logarithm of numbers greater than 1, how we can make use of our standard form in logarithm. So today, I'll be taking us how we can calculate using logarithm on numbers less than 1. So let's start. Let's get started. So logarithm of numbers greater than 1. So when we say numbers greater than 1, logarithm of numbers less than 1. I've done logarithm of number greater than 1 before. So logarithm of numbers less than 1. So when we say numbers less than 1, we are talking about numbers that involve decimal, fraction, and the whole number is 0. That is numbers that are less than 1. You have 0 point something. Maybe let's take for instance, you have 0.35. This number is less than 1. This is 35 over 100. It's less than 1. You have 0.00036. This number is as well less than 1. So when you have this type of numbers, maybe they are multiplying each other or they are dividing each other, maybe 0.0034. All these type of numbers, when they are multiplying, how can we use logarithm to get the solution to these types of numbers? Now, the first thing you need to understand is standard form, of which I've taken that in my previous video, how you can resolve all this to a number in standard form. So you have to change these things to numbers in standard form. So let's take for example the way you have 0.00036. This number is going to be the same thing as 3.6 times 10 raised per minus 1. Times 10 raised per minus 4. So when you have that, the minus 4 is going to go for something, and that's when it brought about. Because if it's just positive number, you don't have any issue. You can just do your computation straight away, but it's having bar. So let's take for instance, we have maybe 0.0046. So this type of number, if you are to check the logarithm of this number, you have the logarithm, number, and then log 0.0046. So this type of number, when you look at it, expressing this number in standard form is going to be the same thing as 4.6 times 10 raised per minus 3. So that minus 3 will go for the bar. You have bar 3 points. This bar is the same thing as this raised per minus 3 that you have here. Then you can just go to your 4-figure table, check. Just check 46 under 0 on your logarithm of numbers. Check 46 under 0. So on logarithm of numbers, 46 under 0, we have 6628. 6628. So this is the same thing as bar 3.6628. This bar 3.6628 is the same thing as if you have minus 3 plus 0.6628, and it is not the same thing as minus, don't think it as minus 3.6628. Don't mix it up. This is quite different. It's not equals to this, but it's equals to this. So take note of that, because when it's going to involve some operation, we are going to perform some operation on all these numbers. You don't mix it up and say this is minus 3.6628. No. But it can be the same thing as minus 3 plus 0.6628. So I think that's about what you need to know about this the introduction. I've explained in my previous video that this bar 3 is the same thing as your integer or your characteristic, while this decimal part is also known as the mantissa. So we are going to perform some operation that will involve addition, subtraction, multiplication, and division on all these numbers, logarithm of numbers less than 1. So I'm going to give us some example. Simplify the following, leaving the answer in bar notation. Simplify the following, leaving the answer in bar notation. So the first one, we have bar 5.7 plus bar 2.3. Bar 5.7 plus bar 2.3. B, you have, let's have bar 6.5 minus, let's have bar 4.2. C, let's take another one. Bar 2.705 plus bar 3.28 bar 3.2836. And then D, let's have bar 1.4256 1.4256 minus bar 5.769 bar 5.769. Okay, let's take solution to this. First one, solution. First question we have here, we have bar 5.7 bar, I will do the 2 on one side, bar 5.7 plus bar 2.3. Let's add 7 plus 3. You have what? You have 10, but you are going to write 0. We carry the 1. That 1, we are adding it to the next operation, to the next addition. So this bar 5, I said, is the same thing as what? Minus 5 plus this bar 5.7, the same thing as minus 5 plus 0.7. So if you add 1 to minus 5, it's going to give us minus 4. That minus 4, you are going to write it as bar 4 in bar notation. So minus 4 plus minus 2. Minus 4 plus minus 2. This is going to be minus 4 minus 2, which is minus 6. And minus 6 in bar notation is bar 6. And that is the answer to that question. The second one, B, we have bar 6.5 bar 6.5 minus bar 4.2. Let's subtract. Now 5 minus 2, you have 3. Okay. Then point bar 6 minus bar 4. Please look up. Bar 6 minus bar 4 is the same thing as minus 6 minus 4, which is minus 6 minus times minus plus. Then you have minus 6 plus 4. That's going to give us minus 2. So we have minus 2. And that minus 2 in bar notation is going to give us bar 2. I hope it's clear. So you have bar 2.3. Let's take the other one. We have bar 2.705. See, bar 2.705 minus, okay, it's plus bar 3.2836. So you know you are including 0 here. So when you had 0 plus 6, you have 6. 5 plus 3, you have 8. 8 plus 0 plus 8, you have 8. 7 plus 2, you have what? You have 9. Point. Now bar 2 plus bar 3 is going to be minus 2 plus minus 3. And that's going to give us minus 2 minus 3. And that you have minus 5. And minus 5 in bar notation is bar 5. We are done with that. Now let's take the last one. You have D bar 1.4256 bar 1.4256 minus bar 5.769. You know you are including 0 on your own here. So let's subtract. 6 minus 0, you have 6. Then 5 minus 9. Not possible, you borrow 1 from here. You have 15. 15 minus 9, that's going to give us 6. So these has become 1. So you borrow 1 to it, you have 11. And then 11 minus 6, you have 5. And then this is now 3. You borrow 1 from this bar 1, it's going to be the same thing as bar 1 minus 1, which is minus 1 minus 1. This will become minus 2. So this will become 13. 13 minus 7, you have 6 points. This has become bar 2. So now you have bar 2 minus bar 5. Bar 2 minus bar 5. Bar 2 minus bar 5 minus bar 5 is the same thing as minus 2 minus 5. And then here you are going to have minus 2, minus times minus, you have plus, and then 5. Minus 2 plus 5, that's going to give us exactly 3. So this does not involve any bar. So this has become number greater than 1. So you have 3.6566. You can see, take a look, the solution to all this question. Now, I'm doing this type of question to get us prepared because these are things you will come across in this logarithm of numbers less than 1. Now, let's take example 2. Let's take example 2. This example 2 will involve the simplification on multiplication and then division. I've done addition and subtraction. So we are doing multiplication and division now. So example 2. Example 2. Simplify the following and leave your answer in bar notation. The following and leave your answer in bar notation. Leave your answers in bar notation. The first one, we have 2.4 times 3, bar 2.4 times 3, B. We have bar 2.823, bar 2.823 times 3. Then C, we have bar 4.16 divided by 4. D, we have bar 4.3217, bar 4.3217 divided by 3. And then E, I'd like to take common. And then E, we have bar 2.5738, bar 2.5738 divided by 5. Let's take solution to these questions. Now the first one is just like your normal multiplication. You have bar 2.4 times 3. Alright, 3 times 4, that's going to give us 12. Right? We are going to write 2. We carry the 1 point. Then 3 times bar 2 is going to give us bar 6. Bar 6. Then you add 1 to that bar 6. You have bar 6 plus 1. That's the same thing as minus 6 plus 1. And that's going to give us minus 5. And minus 5 in bar notation is the same thing as what? Bar 5. So that's the solution to that question. B, we have bar 2.823, bar 2.823 times 3. Times 3. So this is going to give us 3 times 3, we have 9. Then 3 times 2, you have 6. Then 3 times 8, that's 24, you write 4. Carry the 2. Then 3 times bar 2 is going to give us bar 6. Then add that 2 to it. Bar 6 plus 2 is the same thing as minus 6 plus 2. And that's going to give us exactly minus 4. And minus 4 in bar notation is bar 4. So our answer is bar 4.469. Bar 4.469. Let's take the division aspect now. Now for the division aspect, we have bar 4.16 divided by 4. When you look at it, that the number you have can easily divide this thing. You just what? If it can be a multiple of what you have there, then you can just divide straight away. But if it's not a multiple of what you have here, like this divisor, it cannot divide this 4 that you have here, then we should just what? We should just think of another way we are going to do it. I'll show you. So this one now, 4 can easily divide 4 without leaving out a remainder. That is, this is divisible by this 4. So far it is divisible, we can just divide straight away. I believe we all know that our division starts from the left hand side. So how many 4 can you have in bar 4? You have bar 1 point. Then how many 4 can you have in 1? That's what? That's 0. Put a 1 in front of 6. You have 16. Then how many 4 can you have in 16? Is 4. Therefore, our answer to this is bar 1.04. Now let's take the other one. D. you have bar 4.3217 divided by 3. Now, when you see that this bar 4 is not divisible by 3, so far it is not divisible by 3, you think of multiple of this 3 that is more than this bar 4. We know that multiples of 3 are what? 3, 6, 9, 12, and so on. But multiple of 3 that is just next to this 4, that is just a bit more than this 4. Now if I'm talking of multiples of 3 that is more than 4, we have 6, we have what? We have 9, we have 12. But among all, which one is the smallest? Smallest that is more than 4 is what? Is 6. Then you are going to use that we are going to replace this number in form of bar 6. So we say that this is the same thing as bar 4.3217 is the same thing as bar 6 plus, what can you add to this bar 6 to make it exactly bar 4? It is what? It is 2. Then you have what? Plus 2.3217. This is now what we are going to divide by 3. I hope it's clear. This is what we are going to divide by 3. You think of a number that you can, because this is now going to be bar 6 plus 2 plus 0.3217. And that 2 plus 0.3217 is going to be exactly the same thing as 2.3217. So we can say this can be the same thing as bar 6 plus 2.3217 divided by 3. All right. Now, you have how many 3 is 6? So you have bar 2 plus, when you look at it, 3 into is going to be what? 0. You always get 0. Okay, as provided you have done it right, you always get 0 at this first part here. So if it is 0, you can shift it. Then this is going to be plus 0 point. So we can put the point here. So put the 2 in front of 3. You have 23. How many 3 can you have in 23? You have what? 7. You have 7. And what is the remainder? Remainder is 2. Put the 2 in front of 2, you have 22. How many 3 can you have in 22? It's still 7. What is the remainder? The remainder is 1. Put the 1 in front of 1, you have 11. And how many 3 can you have in 11? We have 3. Remainder 2. Then put the 2 in front of 7, you have exactly 27. And how many 3 can you have in 27? That's 9. Therefore, our answer to this is what? Bar 2.7739. That is, bar 4.3217 divided by bar 3 is the same thing as bar 2.7739. Let's take the last one. We have E. We have bar 2.5738 divided by 5. Now, this 2 is not divisible by 5. We have to think of multiples of 5 that will be more than this 2. But the lowest of all the multiples that will be more than this 2. So we can just pick 5 directly. There's no need of picking 10 because it will not be useful. We have to choose 10 because among all the multiples of 5 that is greater than 2, the first one, the smallest one of all, is 5 itself. So we change this thing to what? This can be the same thing as bar 5 plus, what can you add to this bar 5 to make it bar 2? When we say bar 5, it's something as minus 5. What can you add to minus 5 to make it minus 2? It is 3. So you have 3.5738. So with what you have here, we can divide by 5 now. So let's say we have, this is going to be bar 5 plus 3.5738 divided by 5. So dividing, how many 5 can you have in bar 5? Is bar 1. Bar 1 point. Because this 5 in 3 is going to give you 0. So you put the 3 in front of here, you have point. So you have how many 5 in 35? That's going to give us what? 7. So you write 7 here. 7. No remainder. How many 5 is 7? You have 1. The remainder is 2. Put the 2 in front of 3. You have what? 23. 23. How many 5 in 23 is 4? What's the remainder? 3. Put the 3 in front of 8. You have 38. How many 5 in 38 is 7? 7. But when you look at it, the remainder is what? The remainder is 3. Right? That 3, if you put 0 at the back, you are going to have 30. So how many 5 in 30 is 6? So you have something like 6 at the back. But remember I said every everything you do on this logarithm is to 4 significant figure. So we can round this to 4 significant figure. And this 7 can become 8. So our final answer will be 7148. So that's solution to that question. So bar 2.5738 divided by 5 will give us bar 1.7148. So we are going to make use of all this in our calculations, and that's why I've taken my time to show you how to do all these things. So now let's move to calculations. So now remember the rules for the use of logarithm. That when you have multiplication, you find the logarithm of the numbers and then add them together. When you have division, you find the logarithm of the numbers at the numerator and the logarithm of the number at the denominator, and you subtract the logarithm of the number at the denominator from the logarithm of the number at the numerator. Also, when you have powers, we say that you find the logarithm of the number and multiply by the power. And when you have roots, I've explained this in my previous videos. You can check my previous video on the logarithm of number greater than 1. You see everything there. So when you have roots, we said you find the logarithm of number and divide by the root. So those are the roots that we are going to be making use of on this logarithm of number less than 1 as well. Now let's take example 1 now. Or is it example 3? Example 3. Evaluate using table. Evaluate 0.0046 times 14.23. You can also have this logarithm of numbers greater than 1 as well. So we have divided by 0.00035. Let's take this example. Solution. Number so given what you have on the board, 0.00046 and then 14.23 Now, we are going to express this number as a number in standard form. So this is going to be what? 4.6 times 10 raised to power minus 3. So which implies that our characteristic or integer is going to be bar 3 points. And this one, you have what? You are reducing this number. This is going to be 1.423 times 10 raised to power 1. So our characteristic is 1 point. Now that's for the numerator. Now let's check the logarithm table to get what you have here, and then we can deal with the denominator as well. So you check 46 under 0 on your logarithm table. Logarithm of number. 46 under 0, you have 6628. And for this 14.23, you are going to check 14 under 2. 14 under 2. So from the table, 14 under 2 is 1523. 1523 plus difference 3. Difference 3 from the table, difference 3 is 9. You add difference. So this is going to give us 2, 3, 5, 1. So you have 1532. 1532. Alright, remember the rule of logarithm. The rule for use of logarithm says that when you have multiplication, you find the logarithm of the numbers and you add them together. So here we can get the value of our numerator. So let's add. You add. So 8 plus 2, you have 10, you write 0, carry 1. 1 plus 2, that's 3, plus 3, you have 6. Then 6 plus 5, that's going to give us 11, you write 1, carry 1. 1 plus 6, that is 7 plus 1, you have 8. Point. Now bar 3 plus 1. Bar 3 plus 1 is as if you are saying minus 3 plus 1. And that's going to give us minus 2. And minus 2 in bar notation is the same thing as bar 2. Alright, we're done with the numerator. Let's get the value of this denominator. So we have 0.00035. So this, we can just what? Write this number as a number in standard form. This is going to be 0. This is going to be 3.5 times 10 raised to power minus 4. So that minus 4 is going to go for the bar, which is your bar 4. So you have bar 4. Point. Now, what do you check? You check 35 under 0. Check 35 under 0. 35 under 0 from the table is 5441. 5441. Now, when you look at this thing, you will see that the numerator and the denominator were separated by a division sign. And the rule for the use of logarithm says that when you have division, you what? You find the logarithm of the numerator, you find the logarithm of the numbers at the denominator as well. Then you subtract the logarithm of the number at the denominator from the logarithm of the number at the numerator. So we can just introduce a minus sign here to subtract. So let's subtract. We cannot subtract 1 from 0, you borrow 1. So you have 10 minus 1. That's going to give us 9. Then you have 5 minus 4. That's going to give us what? 1. Then you borrow 1 from this 8. You have 11 minus 4. That's going to give us 7. This 8 has become 7. Then 7 minus 5, you have 2. Point. Now you have bar 2 minus bar 4. Bar 2 minus bar 4 is the same thing as minus 2 minus minus 4. It's going to be minus 2 plus 4. And minus 2 plus 4 is as if you are saying you have 4 minus 2, which is 2. Alright. We are going to check the antilog of this. Check the antilog of what you have here. So you move to your antilog table. You check 27 under 1 difference 9. Check the antilog of number, antilogarithm of numbers. Check 0.27. 0.27 under 1 0.27 under 1 is 1866 plus the difference 9. Difference 9, you have 4. So you have 0, 7, 8, 1. 1870. So you are going to write this 1870 as if you are writing a number that has been expressed in standard form already. So you have 1.870, which is still the same thing as 1.87 times 10 raised to power. What is our characteristic here? Our characteristic is 2. So raised to the power of 2. And then if you check this, it means you are shifting this point to the right hand side twice. And our final answer will be approximately 187 to 3 significant figures. You can check that on your own. So that's that. Now, let's take example 4. Let's take another example. Example 4. Let me take a question from the textbook. Using table, evaluate the following. Using table, evaluate the following. A, I can just let me frame question on my own. 0.000349 raised to power 5. Let's do that. And then B, let's use 5th root, or let's use 6th root of 0.000022341. 2341. Solution to this, we are taking it one by one. So, from what you have there, let's write number, then log. You have 0.000349. Now, express this number as a number in standard form. You have what? 3.49 times 10 raised to power what? Minus 4. So our characteristic is by 4 points. Now you check 34 under 9. 34 under 9 from your table. 34 under 9. Ensure you are on logarithm of numbers. Logarithm of numbers. 34 under 9. So 34 under 9 gives us 5428. 5428. 5428. Alright. Now, the next thing we can do here is we have what? To the power of 5. We can come to the conclusion that this thing 0.000349 to the power of 5 is what? By 4.5428 times what? Times 5. So we can multiply now. 5 times 8 is going to give us 40. Write 0, carry 4. 5 times 2, that's going to give us 10 plus 4. You have 14. You write 4, you carry 1. 5 times 4, you have 20 plus 1. That's 21. You write 1, you carry 2. Then 5 times 5, you have 25 plus 2, you have 27. You write 7, carry 2. Okay? Then 5 times by 4, that's going to give us by 20 plus 2. You have bar 20 plus 2. The same thing as minus 20 plus 2. And that's going to give us minus 18. And minus 18 in bar notation is what? Bar 18. So we have got the logarithm of this. Then let's check the antilog. Let's check the antilog. So checking the antilog, you have checking the antilog. You have 71.71 under 4 because there's no difference 0. Okay, there's no difference 0, so we have 0.71 under 4. 0.71 under 4. 0.71 under 4 is going to give us 0.71 under 4. We have 5176. 5176. So 5176, you are going to write it as if you are writing a number in standard form. Okay, so this is going to be 5.176 times 10 raised power minus 18. Minus 18. Okay, as 10 raised power minus 18. You have 0. You can leave it this way because the zeros will be much. 0.00000 zeros in 17 places, then 5176. As simple as that. That's the solution to that question. Now the second one, number, then log. You have sixth root. 0.00002341. All right, let's take this. We then take the sixth root later. So this, you express this number as a number in standard form. You are going to have what? 2.341 times 10 raised to power minus 5, right? And then the minus 5 will go for the integer. And that's going to be bar 5. Bar 5. Point. You check 23 under 4 difference 1. 23 under 4 difference 1. 23 under 4 difference 1. You check. Ensure you are checking logarithm of numbers. 23 under 4. 23 under 4 is 3692. 3692. 3692 plus difference 1. Difference 1. So difference 1 is 2 plus 2. 3692 plus 2. Yes, we have 4963. 3694. So you have 3694. Okay. So divided now. The sixth root now. 0.00002341 is same as bar 5.3694 divided by 6. Okay, we think of multiple of 5 that is what? That is just more than 5. We think of multiples of 6 that is just more than 5 to replace this bar 5 we have here. Then we think of what you can add to it to make it exactly bar 5. So this can be the same thing as bar 6 point, okay, plus what can you add to this bar 6 to make it bar 5 is what? Is 1. So plus 1.3694 divided by what? Divided by 6. So let's divide. So on dividing 6 in bar 6, you have what? Bar 1. Point, this is going to be point. 6 in 1 is 0. So you take this and you write the point. So you take the 1 in front of 3, you have 13. How many 6 can you have in 13? That's going to give us exactly 2 remainder 1. Abi? So you write 2, carry the 1, and put the 1 in front of 6, you have 16. How many 6 in 16? That's just 2. Then what's the remainder? You have 4. Put the 4 in front of 9. You have 49. How many 6 in 49? 6 in 49. That's that's 8. 8. You have 8. That's 8. Then remainder 1. Put the 1 in front of 4. You have what? 14. How many 6 in 14? Is what? Is 2. When you check the remainder is what? 2, abi? So when you put the 2, you put 0 at the back of that 2, you have what? 20. How many 6 in 20 is 3? When you put the 3 at the back of these 2, is the number to be rounded down. So our final answer is going to be bar 1.2282. Then let's find the antilog of this. So you are going to check 22 under 8 in your antilog table. Check 22 under 8. Ensure you have an antilog of numbers. 0.22, 0.22, 0.22, 0.22 under 8. Under 8, 0.22 under 8 is 1690. 1690 plus the difference. Difference is 2. 1690. Difference 2 is 1. So you're going to add 1. You have 1691. 1691. So you're going to write it as if we are writing a number that has been expressed in standard form. So you have 1.691 times 10 raised to power what? Minus 1. The integer. So if you express this our final answer is going to be 0.1691 to first Milan figure. So, and that's the answer to that question. Now I'm going to take one more question that will comprise or that will contain both the multiplication, division, and the multiplication and the division, the powers and roots. So I'm going to take a question that will contain everything. So that's example 5 now. Example 5. Evaluate or using table. Evaluate square root of 23.41 times 0.0000482 over 2348 to the power of 3 times 7th root of 0.0041. All right, let's take this. And let's Let's put square on top of everything. So I'm going to rub this side because it can extend to this side. So solution. Number, then let's have log. The first one you have 23.41, square root of 23.41, square root of 23.41. All right, this, what's the characteristic of this? You just have to reduce this number once, and this is going to be what? 1 point. Now you check 23 under 4, difference 1. I show you logarithm of numbers. 23 under 4. 23 under 4 is 3692. 3692 plus, what can you do? The difference, 3692, difference 1. Difference 1 is 2. So plus 2, you have 4, 9, 6, 3694, 3694, divided by 2. Divided by 2, you are going to have what? 2 in 1, that's 0. This is not involving bar notation, so you don't need to stress yourself. Just divide straight away. So put the 1 back, put point, put the 1 back in front of 3. You have 13. How many 2 in 13? You have 6. You made that 1. Put the 1 here. You have exactly 16. So how many 2 can you have in 16? How many 2 in 16? We have what? We have 8. No remainder. How many 2 in 9 is 4, remainder 1. Then put the 1 in front of 4. You have 14. How many 2 in 14? You have 7. So our answer to this is 0.6847 when we divide by 2. Now let's take the next one on the numerator. So we have 0.0000482. Alright. Express this number as a number in standard form. You have 4.82 times 10 raised to the power minus 5. So minus 5 will go for our characteristic, which is bar 5 point. Let's check bar 5 point. Now you check 48 under 2 for your logarithm table. 48 under 2. 48 under 2. Under 2 is 6830. 6830. Alright. Now we are done with what we have on the numerator, right? But look at the numerator. What separated the two numbers is what? Multiplication sign. So we need to add these two things together. So let's add. On adding, we can get our numerator value. So our numerator value is going to be 7 plus 0, you have 7. 4 plus 3, still 7. 8 plus 8, you have 16, you write 6. Carry 1. Then 6 plus 6, you have 12 plus 1, that's 13. You write 3, you carry 1. Then 1 plus 0 is 1. Then 1 plus bar 5 is the same thing as 1 plus minus 5, which will be 1 minus 5, and it's minus 4. Minus 4 in bar notation is going to be bar 4. Okay? It's going to be bar 4. Then the next thing we do is let's treat these values we have at the denominator. So the value we have at the denominator is what you have here now. The first one is 2348. 2348 raised to the power of 3. This is going to be the same thing as you check 23 under 4 difference 8. 23 under 4 difference 8. You check 23 under 4 difference 8. What do you have? 23 under 4 is 3692. 3692 and then plus difference 8. Difference 8. Check the difference. The difference 8 is 15. 15. So you have what? 7 0 7 3. So you have 3707. 3707. What's our characteristic here? This number is present it as a number in standard form. You have 2.348 times 10 raised by what? Times 10 raised by 3. So our characteristic is 3. So we have 3 point, and this place should be able to contain this thing. How am I doing it this way? Let me bring it up a bit. .3707. Alright, then times 3. So when you multiply by 3, what do you have? Multiplying by 3, we have 3 times 7, that's going to give us 21, you write 1. Then 3 times 0, we have what? We have 0 plus 2, you have 2. 3 times 7 again, 21, you write 1, carry 2. Then 3 times 3, 9 plus 2, that's 11, you write 1 again, carry 1. Then 3 times 3, that's 9, plus 1. You have what? You have 10. So we have 10 points. 10 points. We have 10.1121. Alright, the next one. This next one, we have 7th root of 0.0041. 0.0041. The characteristic of this is going to be what? Bar 3. Thank you. Bar 3. So we have bar 3 points. Now you check 41 under 0 in your logarithm table. 41 under 0 is 6128. 6128. 6128. You are dividing this by what? By 3. So to divide it by 3, you look for the multiple. You are dividing by 7, I mean. You look for the multiples of 7 that is just more than this 3, because this 3 is not divisible by 7. So you have to look for multiple of 7 that will be just, that is just what? More than this 3. And that's 7 itself. 7 itself. So we are going to change this bar 3 to bar 7. But what will you add to bar 7 to make it bar 3? Is as if, what will you add to minus 4 to make it minus 3? And what will you add to minus 7 to make it minus 3? The answer is 4. So we are going to add 4. So here this can be the same thing as bar 7 plus 4.6128 divided by 7. So on dividing, we can have our denominator value. We can have our denominator value as divide. 7 is 7. 7 by 7, you have about 1. Point, because 7 in this 4, we are going to have what? We are going to have 0. So you put 0 in front of this 6. You have 46. So how many 7 can you have in 46? is 6. You write 6. Then what's the remainder? 46 minus 42 is going to give us 4. Abi? So you put the 4 in front of 1, you have what? 41. How many 7 in 41? That's going to give us what? 5. So we have 5. 5. Then what's the remainder? Subtract 41 minus 35. That's 6. So 1.6590. Then when you look at the denominators, the numbers at the denominators were separated by multiplication sign, which implies that we have to add them together. So we are going to add the values of the denominator, which is this 10.1121 and this. We are going to add it together. So before I do that, let me quickly bring this out. The value of the numerator, I'm going to have something like bar 4.3677. Then this numerator and these values are the denominator. To add it together, I'm going to add it together, but they were separated by division sign, so we can introduce minus. So I will add it together now. So let's have 0 plus 1, that's going to give us 1. Then you have 9 plus 2, that's going to give us 11. Then you write 1. Then you have 5 plus 1, that's 6 plus 1, that's 7. You have 7. Then you have 1 plus 6, that's going to give us 7 again. Point. Then you have 10 plus bar 1, that's the same thing as 10. It's the same thing as 10 plus minus 1, which is going to give us 10 minus 1. And that's going to be 9. So now we can subtract them to get a particular value. So on subtracting here, we have 7 minus 1, you have 6. 7 minus 1 again, we have 6. Then this 6, you can't subtract 7 from it. So you have to borrow 1. You have 16 minus 7, and that's going to give you 9. Then you have what left here? It's just what? Just 2. So you borrow 1 from this bar 1. This bar 1 will become from this bar 4. So bar 4, it will become bar 4 minus 1. And that will be the same thing as minus 4 minus 1, which is minus 5. So this is going to be 12 minus 7. You have 5. And this here, right here, you have bar 5 minus 9. That is minus 5 minus 9. That's going to give us minus 14. And that minus 14 in bar notation is going to give us bar 14. Bar 14.5966. Then remember, you have to the power of 1 over 2. So you have everything to the power of 1 over 2. That is, this is a root. We are going to divide our final answer here by 2. So let's divide. So we don't need to stress ourselves, because what we have here, 2. This number you have here, this bar 14 is divisible by 2. So we can just divide straight away. So here, how many 2 can you have in bar 14? You have bar 7 points. Then, how many 2 can you have in 5? That's what? 2. 2 in 5, that's 2. You mean that 1. Put the 1 in front of 9, you have 19. How many 2 in 19? That's 9. You mean that 1. Put the 1 in front of 6, you have 16, right? So, how many 2 can you have in 16? That's 8. No remainder. How many 2 can you have in 6? That's 3. And we've been able to divide this thing. So I'm going to write the antilog this way. So we can check the antilog now. I'll write antilog on top. So we check the antilog. We are going to check 29 under 0.29 under 8 difference. Difference 3. So you check antilog. Antilog 0.29. 0.29 under 8. 0.29 under 8 from the table is 1986. 1986. 1986. Then plus the difference. Difference 3. So we are checking difference 3. Difference 3 is 1. So you have plus 1. So when you add, you have 1987. So you are going to write this 1987 as if you are writing a number that has been expressed in standard form. So we have what? We have 1.987 times 10 raised to the power what? What is our integer? Our integer here is what? Is 7. Also is bar 7, which is going to be minus times 10 raised to the power minus 7. And finally, you just have to shift this point once. So you are going to have 0. Our final answer is going to be 0.000001987. That's the answer to that question. You can see it's very simple. So that's the solution to that question. Now, in case you have any question on this logarithm of numbers less than 1, you can drop your question in under my comment section, or you can simply message me on WhatsApp on my WhatsApp number 08110899920. Good day.